Three amateur astronomers have discovered something with a very ordinary telescope that has puzzled NASA and many scientists ever since. A massive gas cloud is apparently hovering over the Andromeda galaxy, and no one knows what this object is or where it came from. Why is this phenomenon so mysterious that no scientist on this planet has been able to come even close to solving it? And what consequences might this discovery have for our own galaxy? Hold on tight as we unravel the mystery of this startling discovery and show you why no other scientist has seen this before. The crash is inevitable. The Andromeda galaxy is racing toward our Milky Way at great speed. It is already clear that the great marriage of the Milky Way and Andromeda is surely coming. Andromeda and the Milky Way will meet in an inevitable collision, merging into a single massive galaxy. Does that sound ominous to you? Don't worry, this cosmic spectacle won't happen for a few million or billion years. Andromeda may be hurtling 7,000 kilometers towards us every second, but in cosmic terms, even such speeds still mean that a lot of time will pass before Andromeda and the Milky Way finally collide. Since the crash became known, all eyes have again been on the galaxy in our immediate neighborhood. A gas disk as large as the entire galaxy. When amateur astronomers Marcel Dressler, Xavier Strautner, and Jan Sainty set out to take a few photos of the Andromeda galaxy, they pointed their ordinary backyard telescope in the direction of the neighboring galaxy. After a few shots, they couldn't believe their eyes. Had there been a shadow on the telescope, or was a filter out of order? Dressler, Strautner, and Sainty tried several settings and changed the viewing angle several times. Then they began to search the current astronomical data for clues to the phenomenon they had just seen. But no astronomical journey or NASA database described the gigantic object that had revealed itself to the three. The men contacted the American Astronomical Society and reported their sensational discovery. Shortly thereafter, a scientific paper was published by the three in collaboration with some of the most renowned galaxy researchers. But what exactly had the three men found? The object, named SD-SO1, is a huge extended structure, almost as large as Andromeda itself. The structure was only visible through a special filter, except for the blue-green glow of double ionized oxygen blocking all light. Doubly ionized oxygen consists of oxygen ions that have lost two outer electrons. But how does a cloud of ionized oxygen of this magnitude get close to a galaxy? The world of astronomers has been baffled since the discovery was made public. The Andromeda galaxy had been intensively studied for decades. Researchers considered the galaxy scientifically already exhausted, and no one expected to find anything exciting there, except perhaps a few rare individual objects. A mysterious structure as large as the galaxy itself, most scientists would not have imagined in their wildest dreams. Yet the galaxy itself has been imaged and scanned in its entirety many times by even the best astronomers and most expensive telescopes on the planet. Multi-wavelength imaging with X-rays, scans in ultraviolet, and countless examinations in the infrared and optical range had literally not revealed a glimmer of this structure. One may wonder how it could happen that professional astronomers could make this faux pas. Perhaps thousands of astronomers worldwide simply made the mistake of not expecting anything new. They thought they knew the galaxy like the back of their hand, and so they overlooked a discovery of the century. After the scientific paper was published, the discovery was confirmed by 5 telescopes in France, California, and New Mexico, among other places. So the object, named Strautner, Dressler, Sainty Object 1, SD-SO1 for short, has been there all along, only nobody had seen it. What is SD-SO1? After the structure's existence was confirmed, there still remained the big question of what SD-SO1 actually is. Astronomers have considered 4 possibilities, but each of these explanations has a slight problem. Since the structure is right next to Andromeda, it could be related to the galaxy. The cloud is gently curved like an archway and appears in images as if it is curving away from the galaxy. The gas could be an emission from the galaxy itself, but this has not yet been proven. At present, however, there is no concrete evidence that SD-SO1 is a solid part of the Andromeda galaxy. If it is, however, the cloud could be tens of thousands of light years long and represent one of Andromeda's largest coherent structures. An outgassing of the galaxy would most likely originate from the halo. The halo is a spherical collection of stars at the edge of the galaxy. The gas would then be an outgassing of the stellar streams in the halo. However, stellar ejecta known to date invariably contain an enormous amount of hydrogen, and the problem is that the SD-SO1 observations found no hydrogen. If it's not gas thrown off by a stellar stream, how did it form? Now comes the really exciting explanation, which has to do with the superlative galactic event, the merger of the Milky Way and Andromeda. A team of researchers suggested that the outer halos of both galaxies may have already begun to interact with each other. The fused gas in the two galactic halos would compress in a collision, forming a curved structure similar to the bow wave of a ship sailing through water. This would explain not only the existence of the cloud, but also its shape. But again, a problem remains. If the cloud is indeed a byproduct of a galactic encounter, it should not appear so close to Andromeda. Instead, the object would have to be pretty much between the two galaxies. Moreover, this scenario would also be accompanied by hydrogen, and that's missing. Another explanation says that SD-SO1 may be part of the Milky Way and only appears to be next to Andromeda. Medium-sized stars that die repel their outer layers as planetary nebulae. The gas ejected from these stars is rich in hydrogen and oxygen. The central star energizes the gas, and the planetary nebula appears bright in the light emitted by both elements. But again, the absence of hydrogen in this gas cloud argues against this model. Finally, astronomers have considered that SD-SO1 is a remnant of a massive star that exploded in the Milky Way. The violent explosion of supernovae outshines entire galaxies for a few moments, but then the emissions usually give off radiation that is in the ultraviolet or radio wave range. But again, SD-SO1 waved off. Neither radio waves nor ultraviolet radiation, nor infrared or X-rays could be detected in the cloud. It seems that this gigantic cloud is playing a cosmic game of who am I? And astronomers are currently grinding their teeth at this candidate. Next, a blue spectrum analysis was done to try to figure out the mystery of this apparition after all. If the spectrum is blue shifted to the same extent as that of Andromeda, then the gas cloud can be safely determined to be part of the galaxy, and then it would be moving toward us at the same speed. If, on the other hand, it is moving more slowly, it's probably a part of our own. Since the object is quite thin and faint, it required very long exposure times to even detect and scan it with the blue filter. 160 hours were required to detect the doubly ionized oxygen with the Canada-France-Hawaii 3.8-meter telescope. The discovery of SD-SO1 was published in 2023, and the blue light scan investigations are still ongoing as of the publication date of this video. SD-SO1 is not the only mystery. So, at this point, it must remain an open question whether scientists can even figure out what SD-SO1 really is. If the question remains open, this object would not be alone in space. Although astronomers today can already explain the overwhelming number of the material appearances in the universe or classify them into the cosmic context, there are still enough mysteries and puzzling objects. Until today, nobody can really explain dark matter or describe it scientifically. It's not even completely sure that it exists at all. And that, although it has almost become a permanent feature of science. Fast radio bursts or fast radio flashes are another phenomenon that scientists would like to explain, but simply cannot. While coherent explanations have been found for some of the signals, and scientists would love to say that the signals really always originate from magnetars, pulsars, or neutron stars, they can't. Some of the signals, some of which travel millions of light years through space, are so enigmatic that they are among the X-files of astronomy. Recently, the discovery of some stars that rhythmically dim their light once again presented the world of science with an unsolved problem. Since no explanation for the phenomenon was found, scientists now even consider that the stars are dimmed by Dyson spheres. If this is the case, it would mean that extraterrestrial intelligences are at work there. The discovery of SD-SO1 by amateur astronomers shows in this context once more that scientists make a crucial mistake if they think only in dimensions of the known and want to put new discoveries into drawers. The importance of amateurs in astronomy. Amateur astronomers, otherwise known as citizen scientists, also discovered some of the most important signals received by the Organization for Tracking Extraterrestrial Intelligence in Space, SETI. These amateur scientists look through thousands of radio signal data every day, and often they notice the crucial differences much sooner than astronomers who have long since developed expert tunnel vision. Amateurs, often equipped with only modest equipment, have even made some of the most interesting discoveries of modern times. British amateur astronomer Sir Patrick Moore pioneered lunar mapping. Japanese astronomer Yuji Hyakutake discovered comet Hyakutake, named after him in 1996 with a comparatively simple telescope. Citizen science projects such as Zooniverse encourage people all over the globe to exchange ideas with the exciting world of astronomy and cosmology. The platform allows laypeople to browse data from space telescopes from the comfort of their own homes, and the project is now delighted to have discovered thousands of previously unknown celestial bodies. And now, as always, it's your turn. What do you think SD-SO1 really is? And do some of you also belong to the passionate hobby astronomers or own your own telescope?